Okay, so here is what I was talking about last time. As you can see, this is the code that is currently flashed in, which has this GPIO interrupt clear register being written first, and then the data register. And so what you can see is this works exactly as expected, which means every time I press the button, I get this LED to toggle. But if I were to swap these things around, which means if I write this exactly the other way around, and let's build, let's debug again. So now I run, and you can see now that it doesn't do what it's supposed to do, right? So I'm pressing this button, so button press, button press, button press. It doesn't do much, and I don't think it's visible in the camera, but if you look closely here, it's actually possible to see the LED come on for just a very, very small time and then turn off again. So that means that it certainly is getting uh, um, called, which means the ISR gets called, the LED turns on, and then immediately it gets called again, and then it turns off. So of course, the way to debug, or the way I thought of this was, maybe there's something to do with having to do this right at the beginning of my ISR. But as it happens, that's not the case, and thanks to some help from Darshak sir, we were able to figure out what the problem is. The problem is that this particular write instruction writes a 1 to all the bits wherever there were pending interrupts, and writing a 1 causes the interrupts to get cleared. The problem is that it takes a while for this write to actually finish. So it takes a few cycles for the processor to go and write into memory wherever it's supposed to write. But when you perform this write, the processor thinks, okay, I have instructed the write to happen, but the memory controllers and whatnot, whatever are involved, or maybe there is some caching that is still waiting to write this value into memory. Okay, in the meantime, your processor exits from here, looks at this register and says, hey, this has not been cleared, so there's a pending interrupt. So it goes back in and it calls this interrupt again. And in the meantime, of course, this first instruction to write 1 here has gone through and it has cleared. And so basically for every time that the event happens, you get the interrupt handler being called twice. And so the reason why this works, supposing I flip this order around, the reason why this works is that when I do this first, it takes a while. We are still in the ISR handler, and it takes a while for this second write actually to take place. So in the time that we finish this write and then execute the remaining instruction, that is the branch exit, and then come back. So let's go and take a look here. So I'll put a breakpoint in this function here. So when I execute this, now main loop is running. Of course, we are in main, and the moment I press this button, we are going to land in this ISR handler. So there we go. So the moment we land in this, the first thing we do is, of course, write to this register. And the next thing that we are doing, let's go into disassembly. And this is the port F data write. So you can see that this is a read, modify, and then write. So we are doing a modification here. That's the OR, exclusive OR, and then we are actually writing it. And then this is the branch return, ISR return, right? So in this time, there's basically 4, 1, 2, 3, 4, 5 instructions. That's more than enough time for this ICR write to have gone through, and therefore we are safe. So that's why this particular code, it works as expected, and every time I press this, it works. The other thing is, Let's flip this around. Uh, let's flip this around. Interestingly, it works. The code works differently if you are in single step and if you are in run mode. Okay, and that is because again, in single step debugging, the moment you execute the instruction, there's time for it to actually go and execute and finish writing. Yeah, it doesn't count on the clock being on. So that's why that's a problem. Okay, so what you need to do to fix this is basically to go here to your this handler here, right? So this is our handler, right? All I have to do is basically spend maybe another clock cycle or two just after this and make sure that this has had enough time to finish. So what do I do in this time? So what I can do is I can basically do a spurious or basically just waste time. I can just wait for this to finish. So I can just do a write. I can just do maybe cystic count equals cystic count. That's all. So this is basically just going to do a memory fetch, read, and then write it back again. Just waste time for this to go through. So let's see whether this solves our problem. There we are. Now program is running. Now button. We landed up in our GPIO and that's working. So let's disable this breakpoint and make sure that that is indeed happening in a repeatable fashion. So button press, button press, button press. There we are. So everything is working. Instead of that, let's say we don't want to write to some register. Let's see if just writing NOP will work here. So ASM for adding some assembly, and let's just put one NOP here. Let's see whether this is able to do what we expect it should be able to do. So let's put one breakpoint here and run our code. So we have landed in this, and there we go. So we are running. So that also has fixed our problem. So let me get rid of this breakpoint, and then so you can also see these breakpoints here, and you can enable or disable them through this. So now you can see at every button press we get the intended behavior. So basically just adding one little clock cycle there was enough to solve this little problem that we had. So unfortunately, this sort of problem becomes harder to debug when you are doing more things. Okay, so let me just give you an example of the original code that had a problem, and that would have been extremely difficult to debug if it weren't for the fact that we had boiled this down to this minimal example and then figure out what was going on. So just give me a second. I'm going to show you. Let's stop debugging this, and I'm going to show you a slightly more elaborate switch handler function, and then we'll come back to debugging what's going on. Right, so here is the code that I was actually debugging to begin with, and this had the same problem. If I write GPIO port F up here, it seems to work. If I write it down here, it doesn't seem to work, and it was quite mysterious. And let me just show you what happens here. So the idea is as follows. I now have two interrupts enabled. The two interrupts are for two switches. So let's go down here. This interrupt mask has basically switch 1 and switch 2. Both interrupt masks bits are enabled, and so both interrupt switches, both interrupts should be now enabled. And what I want to do is in my handler, depending on which switch is pressed, I want to do a different action. So in this case, if the switch 2 is pressed, then I want to turn on this particular bit, and if the other switch is pressed, then I want it to turn off. So what I expect is that every time I land in this routine, depending on which button was pressed, either the light should turn on or it should turn off. So let's see what we expect and what is really happening. So there we go. So now we are here. This is our switch handler. So let's put a breakpoint here. So now we ended up here. So now let's see whether we are actually ending up here with the correct action. So now we have two switches. Let's try one of them. So let's try this. Indeed, we ended up inside this particular routine. This is we are now going to check which switch it was. Okay, so we got called into switch 2 handler. Now I need to check whether or not it was port F MISR, which is the masked interrupt status, to tell me whether it was switch 2 or switch 1 that was pressed. So let's go and take a look at what MIS shows. So MIS shows 1, okay, which means that SW2 was pressed, and SW2 is this one here. So this is connected to port F0, and this is connected to port F4. Okay, so now let's single step through some of this. So here is the check, and indeed SW2, which is this, was pressed. So we are now going to turn this LED on. There we go. So green LED turns on. And of course, we are not going to end up inside this else statement. So we go right out. Okay. So now what I'm going to do, I'm not going to execute this. I'm going to just go directly into this again. So now we know I have not pressed a button, but I landed up in this again. And so now what is going to happen? I have spuriously landed up inside this interrupt handler just because I didn't have enough time for this ICR write to go through. So I have landed up inside this, and now my code just checks. Is it because of SW2 being pressed that we landed up here? So to do that, it tries to read MIS, and MIS is 0 because, as expected, button was not pressed. So a masked interrupt status is indeed 0. Okay, so what it's going to assume is, okay, button was not pressed, so I should not turn on this green LED. And so let's step. But then this else condition, it assumes that the other button was pressed because we had put an else. We didn't put an else if. Okay, so what happens here is GPIO port F data, and indeed we get this execution of this statement, which is going to go ahead and turn off this LED. There we go. So LED is turned off. Now we are going to go into this ICR write, and in this case we can look at our ICR under GPIO port F, and you can see that even before we have actually written to ICR, port F ICR, there we go. So port F ICR is already 0 because ICR got cleared at the time when we entered this ISR in this interrupt routine, not because this event was actually there. It was only we entered this ISR only because there was not enough time for this ICR to be cleared the last time around. So this time it doesn't matter. So we have exited from this loop, right? So basically what happens is every time I press a button, this loop is going to get called twice. So here we go. So this is the first time this loop got called. I'm not pressing any other button. The moment I say resume, I land up in this loop again. And the next time when I press a loop, press continue again, now we are in main again. Okay, so let's try and disable this breakpoint and then see how this code is going to behave. Okay, so how do you expect this code to behave? Every time we land up in this correctly, this LED is going to turn on, but we are also going to land up in this ISR once wrongly, and it's going to go and turn this off. So let's see whether that actually is happening. And you can see, yes, that is what happens, because this green LED, it does indeed turn on for a very, very short amount of time, but it's almost impossible to see on camera, but it does, I can see that it flashes. So one way to write good code I would say, is to actually write the second condition, which means let's go here, okay? And what is the condition that we really want to write? We want to say that if the if switch 2 was pressed, which means this condition would have evaluated to true, then you turn on green LED. Otherwise, if the other switch was pressed, then only you should take action and turn it off, right? So let's add a condition right here, right? So now I've added that. So if button 2 was pressed, then I should go turn this on, and if button 1 was pressed, only then I should turn it on. Turn it off. Otherwise, I just set this mask to I clear out these interrupt flags, and then I exit. So let's see what happens here. So I'm going to go into debug, and I'm indeed going to put a breakpoint here to see what happens. So let's put our breakpoint here. Let's enable that on line number 30, and now I'm going to run this. Main is running. I press this button. We ended up inside ISR. Now you can see that in this case, because I have pressed this particular button, that is SW2, that causes MIS to be 1, correctly detecting that button 2 was pressed, SW2 was pressed, and therefore we should turn this LED on. So now LED will turn off, but we end up in this ISR again. Okay, and this is our spurious call to this ISR because there was not enough time for ICR to get cleared out, and therefore we ended up here again. But we are safe because now we are going to check, was button 2 pressed? No, it was not pressed. So our code is going to skip over that, but it is also going to check if button 1 was pressed. So the button here, was that pressed? It's going to go and check MIS again for that. And it turns out that wasn't pressed either. So it's basically going to do nothing and it's going to come out. So let me just disable this and show you how this code works in run mode. So now all the breakpoints are disabled. So anytime I turn this on, you can see that this LED is on and this turns it off. So this turns it on, this button turns it on. So now they are working as expected without any issues. Okay, so now this again, by the way, let's just see that, we want to see whether or not our ISR is actually being called a second time or not. So just to check that, what I'm going to do is I'm going to use the red LED to be toggled on one button, and I'm going to use the green LED. I'm going to use the red LED to be toggled every time I actually enter this interrupt. So let's go and see what is going on. So or equal to sorry, I need to do there we are. So what this code should do is every time any button is pressed, it should toggle the state of the red LED, and green LED should be on and off based on which button is pressed. So let's see what should happen here. So now as expected, there we go. So now as expected, code is now running. Let's put a breakpoint right here. Okay, press any button, land up inside this. Okay, and the moment we come out of this, we end up with the same problem. So we are going to get a spurious run of our ISR once again, and the red LED got turned off, right? So if I press this, we land up in the ISR, we turn on the green LED, we also turned on the red LED, of course, but the red LED got turned off because we got called into the ISR once again. So to fix that, as you have seen, what we are going to do is we are simply going to add a no op here. So what is the no op? The no op here is going to be just ASM NOP, stop debugging this, build, and Let's go into debug. So now we are running. We have a breakpoint at line 30. So now we are running. Let's check out what's going on. So we landed up here. Okay. And so now if everything is correct, we should not land up here again because I have not pressed the switch a second time. That's correct. So now we are in main. Switch has not been pressed and we are not in the ISR. So let's try switching the other one. There we go. Press it. We landed up inside the ISR. If I continue, I should come back into main and not land in the ISR again. That's what's happening. Right? So let's disable this breakpoint and see how this code behaves without any breakpoint. So these two switches are going to basically turn on the green LED, turn off the green LED. And every time I press any button, it's going to toggle the red LED. So red LED on, green LED on. Now if I press this again, green LED of course is already on, so it's going to stay on, but red will get shut off. So that's happening. And this is going to shut off the red, shut off the green, but it's also going to toggle the red. That happens. Now next time if I do this, it's basically just going to toggle the red and turn off the green, which is already off. So there we go. So basically we have yellow, green, red, and off. So all four colors we are able to do here. So this is just a quick demo to show you the importance of checking for conditions in sort of a redundant way, and also how to debug problems with ISRs. So moral of the story is that in the lab we were sort of blaming the debounce on the switch. We assumed for a long time that the switch debounce is what was causing the interrupt to get called multiple times, but it has nothing to do with debounce. It has everything to do with this particular instruction not having enough time to finish writing this to memory before we exit from here. Okay, so that's just a quick demo of how to do debugging and how to ensure that these some of these instructions, they're not all single cycle instructions, and depending on what kind of architecture the vendor has implemented, it may take some time for it to actually go through and commit things to memory. So that's it for today. See you in the next video.